Namaste all of you. My name is Dr. Ritu Singh Rajput, Faculty of Agriculture and Veterinary Science. Today's topic is critical state. In thermodynamics, a critical point or critical state is the end point of phase of equilibrium curve. The most prominent example is liquid vapor. Critical point is the end point of pressure and temperature curve, that designated condition under which liquid and its vapor can coexist. At higher temperature, the gases cannot liquefied by the pressure. At the critical point, defined as a critical temperature is Tc and critical pressure is Pc. Phase boundaries is vanished. For example, liquid-liquid critical points in a mixture. Liquid vapor critical points are, for simplicity and clarity, the generic notion of critical point is the best introduced by the discussing a specific example, the liquid vapor critical point. For substances as opposed to the mixture which have been additional state variables and rich phases of, so commonly phase are solid, liquid and vapor. Separately, phase boundaries are pressure temperature combination where two phases exist at the tripling point. The three phases coexist at the liquid vapor boundaries and terminate at the end point of some critical temperature. So, as I told you what is the critical temperature Tc and critical pressure is Pc. At the critical, like in water, critical point is 647.0.96 Kelvin and 22.064 megapascal. It's a critical point where is the liquid vapor that is called liquid vapor critical point. In vicinity of critical point, the physical properties of liquid and vapor change dramatically with both phases. So they have maintained both sides, the vapor and the liquid phase become very similar. For instances, liquid water under normal condition is nearly incompressible, has a low thermal expansion coefficient, has a high dielectric constant at the in excellent solvent of the electrolyte near the critical point. All of these properties change to the opposite. Water becomes expendable, poor dielectric, and the bad solvent for the electrolytes, and they prefer to mix non-polar gases and organic molecules. So this is the liquid vapor critical point. Now we discuss liquid critical point. So in liquid vapor critical point there is some equilibrium, and liquid critical point is a solution where occur critical solution temperature occur at the limit of two phases region of in phase diagram. In phase diagram, in other word, is the point at which is in the phase diagram, as we have told you the low temperature in van der Waals equation, which I have showed you the phase diagram, the at low temperature and a high temperature, as we have discussed in a van der Waals equation. In other word, it is a point at which a infinite stable changes some dramatically variable such as the temperature, which leads to the separation of mixture into the two distinct liquid phases. And show in the polymer solvents phase to the right, two types of liquid critical points are the upper critical solution temperature and the which is the hottest point at the cooling, which include the phase separation, and the lower critical solution temperature, which is the coolest point at the which is heating into the induced phase separation. Thank you. I hope you are satisfied with this section. If you have any query, write down in comment box. And this session is powered by digital version 2.0, Jayoti Vidyapeeth Women University. Thank you.